Great. So I'd just like to start by welcoming you to today's webinar titled Make Productivity, so Advanced CAM Productivity for PowerMill. And also thanking you for investing the time this morning or this evening, as the case may be. So I'm conscious that everyone's very busy. So our aim is to keep today's presentation to 30 minutes, but we will be staying on the line afterwards if anybody has any specific questions. So why have I invited you all to this presentation today? So as I mentioned in the email, I am fortunate in that I get the opportunity to be exposed to new technologies. And when I saw this innovation for PowerMill, I felt it was something that would offer a unique benefit to each of you. So I reached out to Rob and Mike and his team to see if we could explore it a little more. I'm sure Mike will give you a lot more info. But I think the thing that I really want to highlight is that even though the team at SolidCAD is based in Canada, they face almost identical challenges as our tool rooms. So there's more precision, higher throughput being demanded, and that's being asked of an ever decreasing workforce. So it's these challenges that the Make Productivity tool can assist in overcoming. So with that said, and again, conscious of the time, I'd just like to hand over to Mike.
All right. So thanks, Rob. Like Rob mentioned, my name is Mike Belanger. I'm joining you here as an industry account manager, working with SolidCAD over here in Canada, like we mentioned. And I don't know if you want to bring up our bio screens there, Rob K, to maybe kick things off with that if you want to share your screen. That way people can get a feel of who they're talking to.
Am I not sharing my screen? Isn't that comical?
No. So
thank you very much for letting me know that.
Great at CAM, horrible at Zoom. That's okay.
Yeah, we're still figuring
All right.
No, but
how about this? Do we have a blank desktop now?
Yes, we do. Yes, we do.
Very good. So go ahead, continue, Mike.
All right. So as far as myself, just to give you a really quick bio on myself, and as you can see, Rob just brought it up on the screen here. I've taken quite a few roles, and I've had quite a few roles that have led me to where I am today, much like both Robs that I'm speaking to and honestly the rest of our team. You know, I've been a CNC machinist, I've been a 5-axis programmer, I've been an applications engineer, and which all this has led me to the sales world and account management. But today, what Rob is going to be showing you in just a moment is something that could completely change the workflow of your operation. Now, just bear with us, because I will be the first person to tell you that I didn't think this level of automation was possible, but it is. In full disclosure, this is not smoke and mirrors. These are actual practices that were proven out in actual machine shops on complex work pieces. So before I hand it over to Rob, I'll mention really quick that we welcome all of your questions, and just fill them in as they come to mind during the meeting. I'm going to monitor these questions, and we're going to either answer these questions after the meeting is done, or even if I find it's relevant to kind of squeeze one in between Rob's comments, I'll even kind of interject and we can talk about those questions, you know, kind of on the spot. So that's it for me, and I'm going to pass it over to Rob Kobielski now for the technical demo.
Wonderful. Thank you there, Mike. Now, just to avoid further embarrassment, am I sharing the correct screen? Is it a full screen of you, Mike, right now?
You got it. You're good.
Okay, thank you for that. Okay, a little bit about myself first. I joined the manufacturing industry in Windsor, Ontario, Canada in the late 90s. Now, for those less familiar, the Windsor area and our neighbors in Detroit, Michigan have long been known as the automotive capitals of Canada and the US, but really we do have a much larger footprint in the whole of manufacturing and have long embraced emerging technologies like automation. So this really was a great place to, you know, begin my trade and this journey and make productivity, I guess you could say. So now with a bit of a sense of who we are and the experiences we're bringing as a team, you can rest assured that this product has been constructed as a value-added commodity for your manufacturing solution. And it's essentially our answer to the request for an easy and customizable full CAM solution. As Rob had mentioned earlier, our goal is to keep the agenda short and sweet. So we do have time set for the Q&A, but yes, indeed, please type them in anytime you want the questions. The first demonstration we'll be getting into is basic automation with programming optimization. Now, this is going to be followed by a customer case study on advanced applications, do-it-yourself process development, and then we're going to wrap things up with a look at the virtual training modules and assessment tools included with every installation. So I do hope everybody finds this to be a good use of their time, and I look forward to your feedback. Now, I've titled this portion right over here as basic automation, but it's not to mean that it cannot be applied against models of significant complexity. Okay. I'm using the term basic to basically capture the automation of less fussy procedures like roughing and semi-finishing operations with 3 axes. All the while, we are certainly going to be considering dynamic stock conditions to avoid needless airtime. Now here I've got a session of Make Productivity open. And if you're familiar with PowerMill, you're going to see the vast majority of my screen right over here is PowerMill. PowerMill is embedded into our product, Make Productivity, and Make Productivity is essentially controlling it, right? It's taking the wheel. If I expand our toolbar down the left-hand side here, we can see a lot of people using this as the top 3 commands: selecting the machine profile, importing your CAD model, and then running a particular process. Now, before I jump into that straight away, I just want to show you that the project I have open right now has a pretty large tool database and a few other items loaded in the project, but there are no tool paths in this project at all. No tool paths, no stock model, right? Because the process is going to handle all of this. So this basic process was created to work with models of any shape and complexity. And it was also designed to work with whatever tool database you have loaded in your project. So it's just going to apply a filter against those tools and grab whatever specific ones it needs for the process it was designed for. Going to grab the process now. My apologies, that wasn't it. And you know, it's funny, I did this webinar not long ago, and I did the exact same thing. I pulled up the wrong file path. So just give me one moment, everybody. I'm sorry about that.
Never fails, Rob?
And you said that exact response last time too, right?
Did I?
Yes, indeed you did. So sorry, everybody, just give me a quick moment.
So just in case anyone is wondering, because it's one of the first things I noticed, I believe Rob just has his ribbon collapsed right now, which is an option in PowerMill. That's not something that Make Productivity has done. It's just the way he prefers to look at the session.
Yes, indeed. So here's the process right over here. And you can notice it's a .spf file. It's a SolidCAD process file, which, you know, we've included a lot of data, including a lot of instructions that you're going to be seeing popping up on the screen over here. So again, please keep in mind, this one was designed to work with any tool database that you have, right? And, you know, the purpose of that is flexibility, right? Is flexibility. So if your intention is to have a complete automated process that grabs the same tools every single time, that is certainly doable. If you want the flexibility to work with different machine tools and different tool databases, absolutely, that's all possible as well. So I'm just going to be running through the process here and following any prompts that come up on our screen. okay? Now, the terms we've used in this, I mean, we can certainly change this all up. It's just all to say that it's prompting me, the user, every time I use this to give a little bit of attention to specific areas that are perhaps a bit more fussy, or maybe I have really fine detail and I want to create myself a boundary around this area. So that's exactly what this prompt is over here. And all I'm going to do is select an area where I want to not only rough, I want to semi-finish down to a 3mm tool. And at this moment, you can weed out any boundary segments that you're not interested in having, okay? Now, of course, sorry about that. Now, of course, I'm working with a white background right now. You can work with whatever backgrounds you prefer to work with, right? So if you're editing boundary segments, chances are you want to throw yourself a black background or a background with high contrast so you can see a little bit better. But I'm certainly happy with what I've grabbed right over here, and I'm just going to resume with my process. Now, here's where the filter I mentioned is now applied to our process. We're going to start with the largest cutter possible. And in this case, I've only got one 2-inch tool in this database. The next one down is probably going to be a 1-inch tool. And it's agnostic to either inch or metric tools. It doesn't really matter. It's just going to apply the filter based on diameter and geometry, like tip radius, for example. So I was happy with this one here. Next one down is going to be anywhere in the 5/8 range. After that, we're probably getting into the smaller millimeter size tools. Okay. And you just carry on, right? Because everybody's got their favorite tools they want to work with. So you can choose depending on the material you have, the machine tool you're working on, you name it, right? And all I'm doing is just at this moment, I'm going to accept my defaults here on out. Okay. And that process is already wrapped up, actually. It's only 6 tool paths because, as I said, it's roughing and semi-finishing only. But the important piece is the boundary elements were all applied to this. The specific tools I went through were all applied to this. And most importantly, all the stock handling has been applied to this. So all the stock model references and states to ensure that when I calculate this tool path, we're getting an optimized result to minimize all that air time. Okay, so this was the basic process, and it is as quick as that. You can expedite it if you wish to work with dedicated tools, or leave it flexible as such. So complex automation. Now, complex automation, I actually just want to talk about this one, right? Because in a complex situation, we could be getting into multi-axis situations and very massive jobs with all kinds of complexity. So this is an actual customer case study right over here. What it is, if you can almost tell from the graphic, it's a very large cavity grill tool. And I mean massively large with all kinds of data in tiny little areas. And the customer engaged us because their process now, albeit they do use some of their own templates and macros, of course, yields them 100% of all tool paths, right? Because they're programming this rather manually. And when we ran an analysis against a project, we found that they had 133 toolpath calculations for machine operation, as well as 58 redundant calculations. Okay, and those redundant calculations, they're almost unavoidable in a manual adaptation of programming, because at any time we could be calculating a toolpath and saying, you know what, I'm not so happy with this result. Maybe I should have optimized a bit more, or maybe I want to use a different toolpath strategy. So that's what the redundant calculations are all about. It took about 56 hours in total project calculation time, and that was actually spread out over 10 different shifts at this company. PowerMill was estimating 137.5 hours of cycle time, of which 110 of that was cutting time and 27 hours was connection time. Okay, and of course, connection time is very important. You cannot eliminate connection time because that's how you're going to safely engage the material without destroying your cutter, right? But these are all items that they wanted to have brought into an automated state. The figure I want everyone to take note of before we carry on is our calculation time to cycle time ratio. It's a tangible ratio that we can extract from these figures. So it's at 40%. Automating this process, right? This is the make automated process now. As massive a job as it is, with all of the complex detail, we are still able to automate 90% of all the final cutter paths. Achieving 100%, it depends on the complexity of the job, right? But 90% is a target that we're very comfortable in hitting, and we've hit it with this particular job. 56 calculations were for machine operation with 0 redundant calculations because this process was made very specific for this type of work. 1 hour was the active user programming time. The basic process I showed you a moment ago was only really 6 or 7 questions, but in a complex environment like this, you can imagine there's going to be quite a few more questions. So there will be 1 hour of active user programming where now we're soliciting feedback from the operator. How do you want us to handle this particular area, right? Or which particular tool do you want to use here? Or is there a feature on here that's maybe an optional feature? You know, does it have particular engravings? And if so, which engraving do you want to do first, right? When you're done with that 1 hour of active user programming, you can now save off the project and put this one aside for what you can say is lights out calculation, right? You can batch process overnight. Or of course, there are tools in Make Productivity where you can batch multiple projects. And we can look at that a little bit later. Now, on account of 90% is being automated, there is going to be some user time the next day. So we've estimated an additional 4 hours for user interrogation and to complete out the project. The stats we're going to highlight now, 98 hours estimated cycle time, which is quite a bit quicker than in the manual programming process, 80 of which is cutting 18 hours connections. So you can see we've chopped our calculation time to cycle time ratio in half. And most importantly, our programming time to cycle time ratio is now only 5%, right? Because now the user can just take back that time in their day to program another job, set up, what have you, multitask, right? Say I captured that all right there, Mike?
Yeah, and that's what I was going to mention there is this slide. I love this slide because it gives you real numbers. And like I mentioned before, these are actual benchmarks that we ran against local mold companies that do very, very complex work in our area, like automotive lenses, 3-color shots, like multi-stage, a lot of very complex pieces. And one thing that I did have somebody say to me back then is, okay, well, it says PowerMill cycle time was 98 hours. We know that's not right, but that doesn't matter. What we're comparing it to was the previous example. Like, so the customer, I believe, had a cycle time of 135 hours or something, and we got it down to 98. Yes, we know 98 hours on the machine might actually be 150 to 200 hours, but it's something that's relatable that we can measure. So I love that slide for that reason. And even the programming time to cycle time ratio, the numbers that you had in there in the bottom were greatly improved from the previous.
Most definitely.
I've got a question from Brad, and I might just expand upon it just a moment. He said, I like the calculation time, programming time comparison. The question being, what's the typical reduction from manual programming to using this tool? I'd like to perhaps expand that question based on your guys' experience from day one of implementing this tool to perhaps day 180 to day 365, because naturally it's a learning system, so it gets better over time. So what would be a reasonable improvement on day one, after, of course, some customization work, to then, as I said, sort of day 365? Yeah. What would you guys expect, or what have you found?
Not a problem at all. We've done a number of, return on investment calculations, right? And oftentimes it shows very dramatic features. The part that's tough to really articulate here is it depends on your level of programming coming into this, right? Because we've definitely seen some tool shops that exercise some really good programming practices. And then there's going to be other shops that are perhaps less aware of some of the stock engagement or stock handling tools that will optimize and reduce airtime. So it's really a tough figure to say.
It is.
But
I'd
always
really
be comfortable saying recapture it twice the amount of time. I mean, I don't even know. What would you say, Mike?
I guess I would need a live scenario to look at to really analyze it. But one of the things that I always kind of mention here is every environment's different. Like the way the job is on the screen right now, if you give that same job to the same programmer, but 4 months apart, it'll be programmed differently both times. Might be similar, but it's going to be programmed different. Because as a machinist myself, I was a machinist for over 10 years. You walk into work sometimes and you're given a job and you just throw tool paths at it to get the machine running because you're already spinning your wheels. Or maybe you got behind in your programming and the next job was sitting and waiting and you didn't have time to get to it. So again, you're spinning your wheels and you're just throwing tool paths at the job that may be inefficient. This is going to give you a repeatable, predictable solution over and over, and right down to the decimal place in the wrong spot. Everything is going to be done the same way every time. You're going to be able to predict the time and everything. And one big thing that I'll mention as well, and I'm sorry, Rob, if I'm stepping on your toes and you're going to mention this later, but this does not this does not take away the need for a skilled operator. You still need somebody who knows what the heck they're looking at to go over these projects, ensure everything is safe, ensure everything makes sense, it's logical. Because basically what we're doing is taking that machinist, that skilled trade, that skilled worker, and focusing them on the things that they should be focusing on. Because really, that skilled machinist doesn't need to worry about making a roughing tool path at whatever step over and whatever step down. That's not necessarily where their skills should be utilized. It should be in the critical parts of this job to make sure everything.
The critical decision making. Yeah, very well put, Mike. Thank you. So, to that end, right now we've shown you some highly customized and some highly complex ones too. But we do want to make note that a lot of people want to exercise their process. And of course, everybody to become profitable these days, we got to get more and more out of our product, right? So there's more emphasis on creating this automation. Now, we wanted to give our users a tool that was going to be 100% flexible to work with your data. You can actually make a process with zero knowledge of coding, zero knowledge of script. And that's what I'm going to highlight right over here. And I'm just going to jump into this one straight away. I've loaded up another project here. You can see, right? This is a block that I had up earlier, but we can consider this as an exemplar project. And what I mean by that is, let's just say I want to encapsulate these programming processes in every type of job that I bring in. I want to create a process for these toolpaths right over here. What the user can do is manually make your entire project, use your naming convention, use your tools, right? Use the kind of boundaries that you want, and most importantly, your stock management. And once you have this all set, we're going to create a process with a single mouse click to automate this again and again. Okay, so the only thing you have to do is think, well, what's the item I'm not going to be bringing in every time? And that's clearly going to be this model. So I'm going to ditch this model right over here. And I'm going to leave every other entity in this project. And I'm going to use this tool right over here in Make Productivity called Automated Process Macro Builder. Okay. It's going to give you the option straight off the hop to say, okay, well, what do you want to automate? What do you want to bring in every single time? And what I said is every project entity. That's going to include your folder organization, all those items I mentioned right over there. So this is actually happening live right now. Single mouse click, Make Productivity is copying everything. Your favorite parameters, your step overs, your strategies, everything like this. And when it finishes up, I'll just very quickly load the code that it has made, just so we can see there's nothing up my sleeve, right? So this ought to be wrapping up quite shortly. Here it is right over here. Actually, this is your final confirmation. And it's telling you, okay, all you got to do now is you have an automated process. Run this automated process against your new project. And if I crack open Notepad just real quick, here it is, right? 5:26 p.m. This is probably a 4,000 plus line macro, but it is made to completely replicate your project on new models. So I am going to do that right now. And in fact, I'm going to do it in an older version of PowerMill 2019 in a different unit system, right? My source unit system was inch. I'm going to run this thing in metric just to show you that it is going to be completely adaptable for you. Here it is right over here, 5:26 p.m. No machinable models. All right, well, that makes sense, right? So the only thing I've got to do is say, what do I want to cut? Let's say I want to cut this block right over here, and that's the only thing I've done is brought in the block. Let's run this guy. Process may not be fully compatible. What it's saying is my source was 2022, and I'm now running it in 2019 with different unit system. Not a problem. How do you want to handle your block?
Toolpath with a feature that's no longer, that wasn't available back then, I think is the warning, right?
Exactly. You know, it's just a disclaimer to say that, you know, back in 2019, they didn't have things like orientation vectors. Items like this that, you know, advanced users of 2022 will certainly understand. Okay. So the first step is just the first couple mouse clicks to say, how do you want to make your stock, right? How do you want to make your raw block size? So you can select the different axes to expand on, key in whatever value you want, make it based on your global transform, specified work plane, or you could even have the option to pause, allow the user to make it manually, and then continue the process. So here we go. Every item is being created right now. I'll just expand these little headers so we can see what's happening. The stock models have been made temporarily as placeholders. And now every single toolpath entity is being built in this new session. The boundaries are being set. Reference tools are being set. Step over, you name it. Everything is not only being set, but it's being swapped as far as units are concerned, right? So, you know, if I happen to have a 1/4 inch step over, then it would do a little conversion, bring that into metric.
So Rob, would it be fair to say that's a great way to share machining process amongst different staff as well?
Oh, absolutely correct. Because once you generate it, I mean, maybe I generated this one because this is how I want to handle this type of block. And I would name it as such, so I know that, and share whichever operator is going to be working on such a job. And then if you want a cavity process, you can make your own. I mean, that's the beauty of it. You're working with your own project data, and we don't have to make a customizable one every single time for you. You can handle your own. Okay. Now, so here's a perfect question, and this is brought up every time. Well, you know, what if I don't exactly have the same features every single time? It's super simple. All you got to do is have an instruction in the name of the work path. So you might see there's an O in square brackets. That's an optional toolpath. If I don't have runners on this job, I say no. If I don't have vents on this job, I say no. If I happen to have engraving, I can say, okay, yep, give me an engraving toolpath. Boom, here goes the first. And what if I have 2 engravings? There's an option to repeat. Yeah, give me a second engraving toolpath. I want that. Right? And you just go on with the rest of the prompts. So once you get comfortable with developing your own process here, I mean, it's just a matter of your own naming convention. And the better it is, the easier it is going to be to run your automation after the fact. Right? It's wrapping up right over here. In fact, you may have just seen the stock model has been completely populated now with all the states and references at the very end, right? So your final prompt, hey, do you want to take a few minutes and revise your boundaries? Do you want to look at any of these new entities you created? You can say yes, or simply say no, and your automated process is complete. So, you know, I think I went a little over budget on time on that one because I knew it was going to take a bit of time to run through it. But I really wanted everyone to see the flexibility you have and the autonomy you have with this particular tool. So complex custom automation is possible, and obviously self-directed is certainly possible as well. So pretty good on time, not bad. We're a couple minutes over budget, and that was probably because of my clumsiness in the beginning. But I didn't want to race through any of those segments, but I'm glad we're at the Q&A. So, I mean, if there were any other items that kind of came up, or if, Rob or Mike, you wanted to expand on something else here, I'm very open for that now.
Rob, if you could just briefly show the training and assessment component, because, big country, it's hard to get around to train everybody. So,
my goodness me, I am so glad. I'm so glad I've got someone to keep an eye on me here. Thank you so much. You're absolutely correct. You may have noticed that there are a number of auxiliary toolbars, like I guess you could say Make Productivity. We don't quite have enough time to go through them, but this one is a very important piece right over here. This is our training toolbar, where it holds right now 5 learning modules that would bring someone with 0 experience in PowerMill whatsoever up to complete 3-axis programming, 3+2, 2D. I'm sorry, not 3+2. It's not in there as a module quite yet, but 3D roughing, 3D finishing, 2D machining. And each of these modules right over here is a very consumable little segment, right? Each clip in these learning series is from 3 to 6 minutes long, perhaps, right? And they step you through the training quite nicely. So these were based on, training courses that we have done so many times over the years, and we've decided to encapsulate them in a virtual training series and enhance it that much further. Okay, not only are we going to give you all the training series with every installation and Make Productivity here, but I've just brought up a very simple toolpath because we wanted to give some on-demand assessment tools as well to validate, did you get all of the major learning items out of these training series? So the rest of these items down the list, self-test your setup, your active tool, your active toolpath. Okay, and if you run any one of those items, it's just going to simply say, well, what type of report do you want? And it's going to give you some very critical feedback, right? Because there are some pitfalls that newer users may fall into that they're unaware of, like in how you reference the block coordinate system, right? That's a very good one. Or they may not be aware of certain high-speed settings like race line smoothing to arc fit some of these sharp transitions in direction. So if you're unaware of where those items are, use these self-assessment tools. It'll let you know you've missed some of these items. And then you go in there, make corrections, run it again, right? Give you a quick idea. Hey, it's currently evaluating this toolpath at 3 out of 10, so I failed a little bit on that one, right? But you run through your assessment, and this is what's really going to give you the autonomy to handle all your training in-house. Have someone, sitting down here, running through the training series and assessing themselves as they go. We find
we've got a question in the queue here, and this will be a good one. How well does it work with 5-axis programming of complex parts? So, Rob, I'll let you take this one, but I will say, yes, we've absolutely looked at that. It can't do everything under the sun, but we definitely have it addressing 5-axis.
If we're talking about the training assessments, the training assessments are designed to be, if we're talking about automation, then yes, you're
I'm guessing the automation, and I hope I'm getting that right, Ian, but yeah, if it's the automation you're talking about, yes, we have quite a bit of 3+2 and even some 5-axis tools that we have built into current processes already that customers are using.
My thought there is,
go ahead.
Sorry, is there another question?
Yeah, but go ahead. Let's finish up on that one.
Okay. My thought there was, there are going to be so many different scenarios, and we'd probably just need to understand in, better detail. What exactly, how exactly are you going to be using it and such? So I just say, reach out to us, and we'd love to have the one-on-ones. And, we can certainly do online meetings. If you're local, love doing things face-to-face again, right? But here's our contact information at SolidCAD and at DMT. So you're probably familiar with one of us already, but please do reach out, and we can certainly coordinate amongst all ourselves to take a look at your specific process.
I might just expand upon that one with regards to the 5-axis of programming complex parts, though. I suppose a different way of looking at it is, if you can automate and simplify the basics and capture the time, then you've got the time to spend in the value added of the 5-axis complex programming, which is what, as programmers, we're there really to do. We don't need to just drill holes. That is not a great use of a programmer's time. So if the basics can be, if we can take it from an hour down to 10 minutes, well, then you've captured 50 minutes of your time back again. And that can be invested into that high value work. So that perhaps another way of thinking about it is, look where the bulk of the repetitive and the repeated tasks are always done every time, and put that in a box and put it away and make it so you don't even see it anymore. So that's perhaps a different way of considering that. Now, there is a couple more good questions in there, but I think out of Brad and his team, parts that require multiple setups, back and front or top and bottom. Rob, if you want to grab that one.
I most definitely can, and I'm actually going to pull up the PowerMill project again for a moment, and I'm just going to look at this rebuild project here that we did in 2019. And I did this on purpose, and some items I mentioned, others I did not, but I very purposely wrote this automation such that it was going to create varying work plans. So you might see, as I activate these work plans here, there are variations. There are different tips of those items. So if you've got a multi-axis machine, and maybe you want to do a component, and you want to rough this part from the top from your Z, and then do a series of rotations at 90 degrees, you can very much encapsulate that fairly easily with your own user-driven automation, or through our custom applications as well. And in the custom applications, we've definitely gone down that road, because that's a very big item as well. So, it's just a matter of probably setting aside some time with us, so we can not only validate how you're going to be using it, but work with you to even talk to you about creating or tweaking your exemplar project. Because essentially, there's only 3 little instructions that you would add to the name of your particular entity that handle how your automation is going to output. And that's simply creating an exact duplicate of your entity, an optional entity, or an entity that repeats. I hope that addresses it fairly okay.
And there's one, I think, a really good question from Nishant, and I'm going to expand upon it a bit more, because I suspect I understand the background question behind it, which is, like, for example, if we have a PowerMill tool in a tool database, and if that database is shared amongst many people, well, one person can change one of the settings in the tool database, and that then gets rippled out and used by all others. So that's effectively dynamic. Whereas templates, typically speaking, when we save a template and the tool is saved in the template, that speed, feed, cutting parameters, they're kind of set in stone unless you revise the template, of course. So if you wanted to make an extremely global change, you would change the settings in the tool database, and therefore everybody using that tool going forwards will use the updated results. So in context of make productivity, can the template pull tools specifically out of the tool database as opposed to pull them from a template?
It's exactly whichever way you want. And it can definitely be done both ways. And that's simply because the PowerMill gives you so many different ways to go about things. Yeah. And we can essentially automate whichever way you prefer. The reason they give you so many is that, some companies will very happily have a network tool database that is Bible, so to speak, and only pull from there. And others are going to say, hey, you know what? I want to have my local template and I just want to grab that every single time because it's quicker.
Yep.
Totally flexible.
Yep. Thank you. And another question out of there from Brad's team. Inserting of jigs and fixtures. I'll perhaps just ask the question back. Is that jigs and fixtures for work holding, so we want to avoid them, or jigs and fixtures for machining for use perhaps in a, well, I'll say, is it jigs and fixtures for work holding?
Yeah, that's the way I took the question, was any kind of either clamps or, yes, work will need to avoid them. Yeah.
Okay, perfect. Thank you for, yep, yes, work holding, need to avoid them. Perfect.
Yeah, so I think Rob's setting something up here, but yeah, there is a way to identify a number of different ways. I prefer to use by level, but you can do it by color or other attributes, and I'll let you expand on that, Rob.
Well, I think in this context with this company, I wouldn't be out of sorts saying they would bring them in as their own model.
Yep, perfect, perfect.
Yeah, and that's certainly doable. I just took a quick moment there just to turn on the display of the machine tool that also came in with this user-driven process, as well as the fixturing that came in it automatically, right? We see it there set on the table. So, it's certainly doable to a point. The question is always going to remain, if your part is way out there in space, right, in assembly location or something like that, then there will have to be an entity perhaps created ahead of time, and that would simply be from your machine tool toolbar, your model location work plane. But aside from that, your machine tool and fixturing can all come in exactly where they need to be.
Yep. And it is possible that if that fixture was brought in as its own model, as its own CAD model, we could then auto apply the level and say, don't machine, just avoid. So that's just bog standard with the PowerMill.
Essentially set it as a collision setting with whatever buffer distance you want. If you want to stay 6 mil away or whatever the distance is, you can choose, and it will stay away from any of those components.
Yeah, perfect.
The automation actually does work with setups if someone chooses to use a setup. Right now, you'll notice this was rebuilt in 2019, and setups in 2019 was fairly basic. If you hop into this, you really don't have anything going on. But if we go back to the root project, we can see that if we had created a setup and applied toolpaths to it, you can essentially identify a level or set as a clamp with a clearance value, right, tied to that. So definitely doable.
Yep. So I think the statement there is that there's, as well as make productivity, there's also aspects of PowerMill we need to consider, because there's been some pretty cool innovations over the last few years with that as well. So it is possible to apply make productivity a little bit older, but we do things a slightly different way. But we always need to review and revise in context of what is new, the new features of the new PowerMill. So we, if they've created a new button that takes 3 steps and turns it into 1, well, we should use that. We shouldn't just rerun the
most definitely. Yeah,
right. Now, I am very conscious that we've run over time, and I apologize to all, but I hope that you have got some good value out of today, or got at least a bit of an understanding. There is some information up on the screen. Feel free to reach out to me or to Rob and Mike for any further information, and we will be reposting this webinar via a number of socials. I think we'll get that out there. So if there was somebody that you feel should have seen this but wasn't able to join the meeting today, feel free to pass that along.
Fantastic. Okay, thanks again, everybody, and thanks again for setting aside the time.
Lovely. Thanks to all.